Hello students, in this video we will continue with the first chapter in Science 1, that is laws of motion, and in this video we will be studying the three laws given by Newton, and these laws laid the foundation of the classical mechanics. They describe the relationship between a body and the forces acting upon it and its motion in response to those forces. Let's see what these laws are. Let's learn Newton's laws of motion. Let's look at few examples first. A static object does not move without the application of a force. The force which is sufficient to lift a book from a table is not sufficient to lift the table. Fruits on a tree fall down when its branches are shaken. An electric fan keeps on rotating for some time even if it is switched off. Now, all these sentences are related to inertia. So, in all these cases, we can find inertia. Well, inertia is related to the mass of the object, and as mass is the quantity of matter in a body, we need to exert more force to push a heavier body. And so, heavier objects offer more inertia. Now, Newton's first law of motion also describes this property and is therefore called the law of inertia. So, Newton's first law can also be called as the law of inertia. So, the first law given by Newton, or the Newton's first law of motion, or the law of inertia, states that an object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. Let's understand this with an example. Now, we all have played tug of war. Till the force applied by both the sides are equal, that is, till the forces are balanced, the center of the rope is at rest. And as soon as the applied force becomes unequal or unbalanced, that is, at one place the force becomes greater, so a net force gets pulled in the direction of the greater force and the center of the rope shifts in the direction of the greater force. So, when an object is at rest or is in uniform motion, it does not mean that there is no force acting on it, but actually there are number of forces acting on it, but they are cancelled by one another, and so the total force is zero. Newton's first law explains this in the form of inertia, that is, the inability of an object to change its states of motion on its own. We have all seen that any object cannot change its motion on its own unless some external force is applied. It also explains the unbalanced forces which causes a change in the state of an object at rest or in uniform motion. Newton's second law of motion. It explains about the change in momentum. Let's understand momentum first. Momentum is the product of mass and velocity of an object. Let's understand this with an example. If your friend drops one plastic ball and one rubber ball from the same height, which ball will be easier for you to catch? Well, it will be easier for you to catch the plastic ball as rubber ball is heavier and the force required to stop a rubber ball will be more than a plastic ball. Hence, it will be easier to catch a plastic ball. Also, ask your friend to throw a ball at a slow speed and then ask the friend to throw the same ball at a greater speed. Which one was easier to catch? Obviously, the slow one. This means that the effect of the force depends on a property related to both mass and velocity. So, momentum is the product of mass and velocity. Momentum is denoted by the symbol P, and P is equal to mass multiplied by velocity, that is m into v. So, Newton's second law states the rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. Initial momentum of an object is always m into u, that is mass into initial velocity. As we know, momentum is equal to mass into velocity. So here initially, when the object is at the starting point, that time the momentum is m into u, that is mass into initial velocity. Then final momentum is m into v, that is mass into final velocity. Rate of change of momentum is equal to change in momentum upon time, whatever the change in momentum occurred from initial to final. So the rate of change of momentum is equal to, that is final minus initial upon t. Here m we will take as common, v minus u upon t. Now children, do you remember acceleration's formula? A is equal to v minus u upon t. So instead of v minus u upon t, we can take A. So this is equal to mass into acceleration. Now we know that rate of change of momentum is equal to mass into acceleration. But according to Newton's second law of motion, the rate of change of momentum is proportional to the applied force. The rate of change of momentum is mass into acceleration. So mass into acceleration is proportional to force. Now proportional we will convert it into as constant. So F will be equal to K into MA, that is mass into acceleration. Well, K is a constant and its value is always 1. So our final answer is force is equal to mass into acceleration. Let's learn Newton's third law of motion. Newton's third law of motion states that every action force has an equal and opposite reaction force which acts simultaneously. Let's understand this with an experiment. Now, many of y'all must have tried these experiments many times at your home. So, the experiment is to take a plastic boat and make a hole at its rear end. Inflate a balloon and fix it on the hole in the boat. Release the boat in water. What happens to the boat as the air in the balloon escapes slowly, and why? So, the boat moves in forward direction as the air in the balloon escapes with the force in backward direction. Through the hole, it exerts equal and opposite reaction force on the boat. This makes the boat move in forward direction. So indirectly it means that forces are always applied in pairs. When one object applies a force on another object, the later object also simultaneously applies a force on the former object. With this we come to know that the forces between two objects are always equal and opposite. The force applied by the first object is called as action force, while the force applied by the second object on the first is called as the reaction force. Let's now learn the law of conservation of momentum. The law of conservation of momentum states that when two objects collide, the total momentum before collision is equal to the total momentum after collision. Let's derive the equation for the law of conservation of momentum. Suppose we have two objects, object A and object B. Let the mass of object A and object B be m1 and m2 respectively. The initial velocity be u1 and u2. The final velocity be v1 and v2. And the force that will act on both the object be F1 and F2. As we have two objects here, so we have taken two values of each. That is, for mass we have taken m1 and m2. For initial velocity we have taken u1 and u2. Final velocity we have taken v1 and v2. And force we have taken F1 and F2. Now suppose the two objects collide each other. So the momentum of A after collision will be equal to m1 into v1. Now how it is equal to m1 into v1? As we have already learned in the Newton's third law of motion that P is equal to m into v. That is mass into velocity. So here momentum is of object A is equal to m1 into v1. Now, as per Newton's third law of motion, A will also exert equal force on B, but in opposite direction, and this will change the momentum in B. So now the momentum of object B after collision will be m2v2. The momentum of object A was m1v1 and for B is m2v2. Now as the forces are applied in opposite direction, so F2 is equal to negative of F1 because of the opposite force. Now we know force. What is the formula for force? That is mass into acceleration. So here F2, that is for the second object, is equal to m2 into a2, that is mass of second object into acceleration of second object, and F1 is equal to mass into acceleration of first object. But here it is negative as the force is negative. Now we know the formula for acceleration. Acceleration is equal to v minus u upon t, that is final velocity minus initial velocity upon time. So instead of acceleration, that is we will put the formula for acceleration. So m2 into v2 minus u2 upon t is equal to negative of m1, and instead of a1 we will again put the formula for acceleration, that is v1 minus u1 upon t. Now as t was common, we have removed t from here. So what is left with us is m2 v2 minus u2 is equal to negative of m1 v1 minus u1. After opening the brackets, you just have to apply simple maths and our final answer will be m2 v2 plus m1 v1 is equal to m1 u1 plus m2 u2. So that means the magnitude of total final momentum is equal to the total initial momentum. With this we come to know that both the magnitude is same. The magnitude of total final momentum and the magnitude of initial momentum is same. So that means if no external force is acting on the momentum remains constant and it does not change. With this, we complete the first chapter in Science 1, that is Laws of Motion. I hope you all have understood. Thank you for listening. Bye bye.